Good morning everyone. In today's video, we are going to start new chapter of our book, chapter 15, Congruence of Triangles. In this chapter, we are going to study about introduction to congruence, congruence of line segments and angles, congruence of plane figures, congruence conditions of triangles, in which we'll study 4 conditions. First is SSS, means side side side. Second one is SAS, side angle side. Third is ASA, angle side angle. And fourth is RHS, which stands for right angle hypotenuse side. Let's start with introduction. In daily life, we come across various figures and objects. According to their shape and size, we can classify them into 3 categories. First category is object with different shapes and different sizes. For example, square, triangle, pentagon, hexagon, octagon. There are many shapes. Second is object with same shape but different size. For example, teddy bears. Some teddy bears looks identical but have different size. And in the same way, we can say that the leaf of a tree have different size but same shape. And the third one is object with same shape and same size. For example, pen of same company. And we have many more examples of these 3 categories. In this chapter, we will study about the figures which have same shapes and same sizes. If we take 5 clubs of identical cards, they look exactly the same. And if we move these cards and place it on the top of the other, then the card will coincide exactly. Now let us observe these 2 figures. In first figure, quadrilateral have same shape and size. But in second figure, 2 right angle triangle have same shape but different size. As this quadrilateral has same shape and size, they are known as congruent figures. And these 2 right angle triangles has similar shape but they are not congruent as the size of these 2 right angle triangles are different. Therefore, we can say that in geometry, when 2 figures or objects have the same shape and size, or if one has the same shape and size of the other, then that figure are known as congruent figures. And the property is called congruence property. In other words, 2 shapes are said to be congruent if they are of the same shape and size. That is, the corresponding sides of both shapes are the same length and corresponding angles are the same. We use this symbol for congruency and it is read as congruent to. If a shape A is congruent to shape B, we say A is congruent to B and we can write it as like this. Shapes which are of different size but have the same shape are said to be similar. Now the next topic which we are going to study is congruency of line segment. To check whether 2 line segments, say AB and CD, are congruent or not, trace a copy of line segment AB and superimpose it on the line CD. If they cover each other completely, then the 2 line segments AB and CD are congruent, else not. Therefore, if the line segment AB is equals to line segment CD, we can say that the line segment AB is congruent to CD. Therefore, from the above, we can conclude that if the 2 line segments are of equal length, the line segments are congruent, and if the 2 line segments are congruent, their lengths are equal. Now we'll discuss about congruence of angles. To check whether 2 angles, say ABC and XYZ, are congruent or not, trace a copy of XYZ and superimpose it on angle ABC such that Y falls on B and ray YX and YZ falls on ray BA and BC respectively. If XYZ covers ABC completely, we say that angle ABC and XYZ are congruent. Therefore, if angle ABC is equals to angle XYZ, we can say that angle ABC is congruent to angle XYZ. So, from the above discussion, we conclude that if two angles are of same measure, the angles are congruent. And if two angles are congruent, they are of the same measures. Now, the next topic is congruence of plane figures. Now we all know that what is plane figure? Square, rectangle, circle, triangles, these are called plane figures. So let's start with congruence of squares. To check whether two squares say ABCD and PQRS are congruent or not, trace a copy of ABCD and superimpose it on PQRS such that A falls on P and the side AB, BC, CD and DA fall on sides PQ, QR, RS and SP respectively. If square ABCD covers the square PQRS completely, they are congruent. So we can say that if the line CD is equals to RS or AB is equals to PQ, we can say that square ABCD is congruent to square PQRS. So from the above discussion, we conclude that if the length of their side is same, the square are congruent, and if two squares are congruent, the length of their sides are always equal.